Everybody. We've got Elton Smith and Todd Train from SolidWorks dialing in. Elton's going to take you guys through a quick overview of mechanical conceptual, and then he's going to turn it over to Jesse Batwinick and myself, and we'll walk you through the actual tool and the interface and give you a product demonstration. Throughout the meeting today, you guys can type in your questions in the question or chat window in the webinar panel, and then since there's 4 of us on here, we'll be able to answer your questions as we go in the chat box, and then at the end of the session we'll just do a quick double check and make sure there's any outstanding questions left that need answering, and we'll cover those at the end as well. So we're going to schedule this for about an hour's time, and Todd and Elton are in one location. Jesse Batwinick is actually sitting in our Colorado office, and myself and Beverly are sitting in Minneapolis. So we're going to do some true collaboration here for you, show you guys how these tools work real time, and hopefully you'll get a good picture for it, what the software is. And without further ado, I'm going to kick it off to Elton. You're going to be looking at his screen for starters. Elton?
Yeah, thanks, Jesse, and thanks everyone for joining us this morning. So let's talk really quick about just at a high level a typical design process. So a lot of the users that are on the phone with us today use SolidWorks as part of the detailed design process, and certainly an overlap into concept design. Historically, SolidWorks as a company has been really good at developing products that fit well into this process, but when you start to peel back the layers of what we actually mean by concept design and some of the processes that individuals go through here to come up with new ideas and create new products, there's a lot of different things that are being done that are definitely outside of a traditional CAD environment. How many times have you sat down with somebody and sketched out an idea on a piece of paper, maybe even a napkin? It's safe to say that a lot of companies will collaborate with individuals maybe in different departments or just inside of an engineering team in a boardroom with a whiteboard, sketching ideas on a wall, having a conversation about how something might work, what sorts of challenges the product might need to overcome. But at some point, a prototype has to be made. And for some companies, that means building something physically. For other companies, it might just simply mean going to a CAD environment to validate whether or not that mechanism or that product is going to perform the way it's intended to. So I want to go into a little bit more detail about what we're talking of here and for concept design in a mechanical environment. As I mentioned before, it's safe to say there's a lot of paper and whiteboard that's being used very early, and really I like to think of this part of the process as on a piece of paper there are no limitations. Really, you're limited by your own creativity. But that's also part of the problem, because at some point you have to dimensionally verify that, yes, in fact, my mechanism will work the way that I want it to. Will my parts move the way that I need them to? So this we see being done largely in 2D. Sometimes 3D models are introduced here. But certainly what's not being introduced here, or typically not friendly to this environment, is the structure that a typical parametric type modeling environment enforces. In SolidWorks and every other parametric modeling software, very quickly the user must define parts and assemblies. And furthermore, those sorts of structures that traditional parametrics require hinder the creativity of the end user. So at some point, lots of iterations are happening here. Might go back to paper, throw away the idea, start over again, whatever that might be. But at some point, the engineers, designers come to an agreement. There's an approval that, the concept we have is the one we want to move forward with. And so I think of like the downstream process, the production 3D part of it, where now as an engineer or designer, I'm concerned about assembly structure. I'm probably also concerned about features that are meant for manufacturing, like draft or fillet, those sorts of things. And then, of course, at the very back end of this, we have 2D drawings that are made specifically for manufacturing purposes. And so when we look at this process overall, and we think of the tools that are used in today's working environment, SolidWorks as a company has identified perhaps a gap in our current product offering, a place where we could probably develop some technology that would be very helpful up front in this collaborative environment of concept design. Enter mechanical conceptual. Just real quick to paint a picture, we see this as being a piece of software that's used up front in that concept design and is complementary to an existing SolidWorks working environment. Some key points that I want to point out here in the concept design phase. Number one, think about how much time is spent developing ideas into concepts. You might, as a company or as an individual, might not have this particular line item, this concept design phase, mapped out. Maybe it's just seen as part of your overall engineering time. But if you really start to think about how much time is spent doing these tasks, it'll help put things into to focus here. Think about also the frequency of change that occurs while you're going through these concepts. And then finally, who needs to communicate while this part of the process is going on? A lot of times, depending on the company, depending on the market that the company serves, you might include, your customers, perhaps your suppliers and vendors. Also, you think of other departments inside of the company, maybe sales and marketing or the executive team. There's lots of stakeholders that might be included to communicate and understand what these concepts really mean. When I think about those things on a timeline, I think of typically a lot of changes happening very early in a project timeline, and when changes occur, there's probably people that are giving a thumbs up or thumbs down to a change that might have happened. So there's a lot of communication that goes on there as well. In fact, our customers have told us that roughly 30% of their overall project time is spent in this concept design phase. And in that concept design phase, they also tell us there's roughly 50% more design iterations in the concept. One more thing to point out here is that if you're spending a lot of time making changes here, the whole point is to get to the right idea as quickly as possible, or perhaps even get to multiple correct ideas so that you can offer variations of a product. Also, almost 100% of our customers and companies in general have told us that they communicate with people outside of their engineering department. And so just one last point to make here is that overall today what we're going to be speaking about is this upfront roughly 30% of your project timeline, where you're going through lots of design cycles, communicating with lots of different people in different departments, sharing ideas, trying to get to the right solution or multiple right solutions in that time given. And so with that, I'm going to let the technical guys take over here.
Okay, I'm going to go ahead. Thanks, Elton. That was a great overview. I'm going to go ahead and switch the screen over to mine, if you will. So I'll make myself the presenter and take control over here. And a couple things that I want to share with you folks is a little quick overview of what the some of the places you guys can go to get this information, after you've seen here today the demonstration. And also I'm going to give you a little background on what Jesse Batwinick and myself are actually going to be showing you as far as a story or a case study. So real quick, I'm just going to pop into the SolidWorks website here, just so you guys get a look at where to go if you want that additional information after today. So on the main page, if you go to products here and just kind of scroll down, we've added the mechanical conceptual choosing here on the product offerings on the main page. But the reason I wanted to show you this link is that obviously there's some sales and marketing type stuff here for you to look at, but at the bottom of the screen we've actually got 3 customers with testimonials and case studies, and you can watch these videos. They're decent length videos, and you can get a feel for how people are already using this technology in production. So if you guys want to look at those 3 videos, great place to go. And then some white papers and data sheets down there too. Just I know it's always hard to kind of find the information with so much stuff being out there. But products tab on the SOLIDWORKS website, and you should be able to find it there. And then what we're going to do here for the live demonstration is walk you through sort of a conceptual design of a new product with a new client of ours. So we're going to be building this 55-gallon drum lifting machine. It's a mechanical device that's meant to pick up and dump the contents of a barrel into the hopper. So obviously the dumping motion is really important depending on the contents of that barrel. You don't want to be spilling and sloshing or losing material. So let me just get through here. I wanted to show you guys just real quick. Elton went over this, but why are we doing this? These are some of the challenges. Elton talked about the 31% of the design time, but the tools are really allowing you folks to stay connected with each other anywhere in the world on multiple media types. You can sit down at a Windows machine and run the software. You can be one of the external stakeholders and connect through an iPad or an iPhone or a web browser on your laptop. So we're going to try to demonstrate all this stuff today, but these are kind of the 4 big things here that make this software what it is on the left here. So what we're going to do is kind of store all of our files out there in the cloud, if you will. Jesse and I are going to be able to collaborate real-time anywhere. So as we save and share data and design concepts, it'll all be stored out there and accessible anywhere in the world. So the first step here is we're kind of going to go through generating some ideas. What will work in this barrel lifting device. We're going to walk through some range of motion type scenarios with 2D and 3D objects together. We're going to allow other people to come into the process and pick the design that we want to move forward with. So that iterative process will be captured digitally in blog postings, and I'll show you that here in a second. And then we can focus on the design, and as that design is being developed and iterated, we can always update all the other stakeholders wherever they may be and however they want to connect in. Then, for the sort of the mechanical portion, we can do live co-reviews in the software and whiteboard and mark up designs real time with each other. And then we can choose, a final digital design before we ever take it to that detailed manufacturing and production world. But the main question is this design going to work, before we get to detailed models in SOLIDWORKS? So that's our goal here, is to find out if it's going to work before we get really deep into the costing of it. So what I thought I'd show you guys up front here is jumping into the well, a couple things. So I'm just on my web browser here, and I'm going to bring you into a public community. So we can base our collaboration on what are called communities out there. They can be public or private, depending on who's participating. This is an example of a public community where you can post, read, and interact with people on all sorts of different topics. Okay, so this is sort of like a public channel, if you will. And then what I'm going to do next is jump into a private channel here. So I'll go ahead and log into my private world. And this is kind of the dashboard that everybody's presented with. And you guys can configure this dashboard per user. You can see I've got some widgets here showing my activity and all my communities that I'm a part of, and then other news feeds and things like that. So if you take a look, in the upper left-hand corner, I can actually go into different areas of the 3D experience here. So I'm going to go kind of to my 3D Swim community here, and this would let me access one of my private communities here. And this is a community we've set up to track our barrel project. So we've got some blog postings here, final concepts, lift and tip concepts, and design requirements. So if I'm just, on my iPad or on my laptop or on a computer somewhere, I can always come and hit these things and find out the status of the project. So here's the design requirements we posted. We've got some supporting documentation that people can download and read. This happens to be a PowerPoint or a PDF. I can real-time add comments to any of these postings. So this would be the majority of the stakeholders that aren't actually pushing the buttons in the mechanical conceptual CAD system. They have, real-time access to the activities. Okay, so this is kind of stuff that we've created ahead of time just to show you what a community would look like. We've got home, blog, media, iQuestions, and this can all be laid out per project. And then I'm going to jump into the actual software here, my mechanical conceptual software, and kind of bring it up and show you that when I'm in the software, I also have over here on the right-hand side of the screen access to those same public and private communities. So I can see all the blog postings, and I can actually add blog postings real time as I'm kind of going through that design phase. So that's a quick overview of just sort of the interface and the communities. But I think what we'll do is we'll jump in and take a look at Jesse Betwinnick's screen here and walk you through, what would it be like to sit down and use this software sort of real time, and then we'll do some collaboration as we go along here. So can you grab the baton there, Jesse, and take over?
I don't know can I switch the screen?
Yeah, you should be able to say make yourself the presenter. I'll do it here.
There we go. All right. You guys see me okay?
Yep, looks good here.
All right. Perfect. Okay, so as Jesse Orman was saying, in this specific example, we're going to be walking you through a project, and so here we have some basic design requirements. The general idea here is we have a barrel that has, some trash or liquid, solid, you name it, and we want to lift that barrel up and dump the contents into a bin system. Most of this information is just some general design requirements, but I'll be actually walking you through how we're going to design that inside of Mechanical Conceptual. So we have a starting point. These are just some general components that I need for my overall design, but I want to create the linkage system. So what I have done here is created it's called a concept sketch. I mean, it's just a normal sketch, and all I did with that is outline the important pieces just with a simple sketch outline. So what I'm going to be doing here is trying to replicate this image right there. Again, this is just what our end goal is going to be. So what I'm going to do is just edit the sketch. Just, the user interface is very similar to SOLIDWORKS. You have sketches, you have features. The process for editing them is going to be very similar. So if you're already a SOLIDWORKS user, the interface on this is going to be pretty easy for you. Now to clean up my model just a little bit, I'm going to hide some components in the back. I don't really need to see those at this time. And I can hide that one as well. And we don't need to see that one either. And I guess I can leave that in for now. Okay, so I want to, again, create this layout right here. So I'm just going to sketch out a couple of shapes. So down at the bottom, just as an overview of the interface, this almost takes over for what's called the command manager inside of SOLIDWORKS. So we have features, sketches, assembly. We'll be getting to motion to see this thing moving on us. On top of this tab, you can use mouse gestures. Okay, anybody who's used SOLIDWORKS might be familiar with this. Just hold down your right mouse button and you can activate a tool very quickly, and you can of course use keyboard shortcuts. So in my case, I'll hit R and I'm now drawing in a rectangle. Hit C for circle, etc., etc. So I'm just going to draw out a general shape here and place that in right there, and I'll define this a little more precisely in a minute, but what I want to show you is the ability to combine all of these shapes together with one another. In order to do this, you just hold down the Control key to select multiple items and use this balloon. You have three options. You just add, subtract, or combine, or common, I should say. Add them together, and it automatically trims away the unnecessary details for us. Let me try that one more time. I think I made a bad click. Let's try that one more time for this one. This time I'm going to be, let me recreate that circle. I might not have aligned that properly. There we go. That's what I'm looking for. All right, and then this next segment, I'm just going to remove away that material. So this process is almost you can think of it as a layout sketch, which will encompass just the geometry that I want, so I don't have to manually trim out that information. Now, I'm going to tie this down a little bit further, so we can use relations just like inside of SOLIDWORKS. So again, if you're familiar with that interface, the transition will be very easy for you. But one of the nice tools about this is you can very quickly define the shape of this geometry. All you have to do is select on a single entity, or you can control select to get that dimension to come up. And all I have to do to size that is just left click on it and, not 15, let's get that to 150. Ooh. Those tangents. Ooh. Didn't seem to like me doing that. Let me just make sure that doesn't move on me too far. There we go. Set that back up to 150. All right, and then we have another dimension, radius of 25. I'm kind of fumbling my numbers here. And then we have a diameter of 20 for this one here. All right, and I want to take that shape and I'm just going to copy it. So I'll hold on my control key, select that inside boundary and just drag off, and now I've created an exact replica of the same shape. So I'll apply the similar relations, make that collinear, define a distance between these two parallel lines at 50, and then I will lock the overall position of that by defining it from the very bottom as 600. And let me just set that to 25. All right. So I have my beginning parts, but I need some pieces to connect to. So I'm going to, again, copy these two shapes, drag it off. There we go. And I can very quickly spin this around. I'll show you another way that we can do that a little bit later, but we just have some quick icons to sort of snap this into place. So we will, again, just to position this properly, make this collinear with the center of our imaginary beam here. There we go. And we can leave that at 50, and I'm going to size this to drop that dimension in right about there. And let's actually scoot that up just a tad. There we go. I just want to make sure that this is all locked down in place. I guess we don't need that dimension. All right. I don't need that to be so big. All right. So I have two more of my linkages, but I need to sort of span the distance between the two of these, so I'll just use a simple slot feature here. Slot sketch, draw it in right there, and do the same thing over here. So I have all of the necessary entities inside of the sketch, but I want to actually see what kind of motion is this going to undergo. So all I have to do is turn on this mode in the upper right hand corner. It's called mechanism mode, and everything has now been sort of fully defined, if you will. Oop, except for that item right there. Let me tie that down a little bit further. Not sure what I missed there. Let's see if that locks it down a little bit better for me. That's what I'm looking for. All right, so as I start to move this around, you can see how the individual pieces start to interact with one another. And obviously this is not a good design. I want this barrel to be tipping forward into my bin here. So I'm going to have to make a couple of design changes. So let me get that back to its original position. One of the changes is I'm just going to adjust this up a slight amount. We'll drag that up to, say, 250, and might as well adjust this up a little bit as well. Drag that up to about 100 and see what kind of difference that makes. So you can see just with those two really small dimension changes, the motion of this changes very drastically. So I have the general concept down. I got it moving in the direction that I want it to go, but I want to be able to demonstrate this concept to a colleague, to a customer, you name it. So what I'm going to do is run a motion study on this. So we'll just go ahead and turn on the motion study, and I'm going to be doing a rotary motion. Let me actually get this scooted out of the way here. And I'll do a slightly smaller tree. And we don't need that to generate just yet. All right, so I want this component here to be rotating at a specific angle, and I want to rotate that 120 degrees over a period of 2 seconds. And I'll just click OK to confirm that. Now that is going to rotate this up 120 degrees, but I want it to also rotate back to its original position. So I'm just going to add in one more rotary motion, again selecting the same item, angle, and in this case I'm going to delay it a little bit. So I don't want it to rotate in both directions at the same time, so I'll just kind of offset this by 3 seconds. So this is almost a timeline. I'll kind of show you here with a full timeline. So it's going to rotate up 120 degrees for a period of 2 seconds, and then it's going to rotate back 120 degrees over a period of 2 more seconds. And let me just make sure, yep, I did not put 120, so let's go, and I also want to flip that direction. All right, and let's go ahead and calculate this out. So it's a little slow at first, just as it's calculating each of the frames, but I'll play it again here in a second once it has finished doing its calculations. Almost done there. And back to the beginning position. All right, so let's start that from the beginning. We'll just play it. There you go. You can see it goes a little bit smoother. And with the 120 degrees of rotation, you can see how it does not go as far as I want it to go. So I'm going to have to make another design change to this. So I'm going to go ahead and just kind of move this over a little bit, bring it a little bit closer, and we'll drop that to about 50. Let's see what kind of design change that makes. We're going to calculate that out. So with the specific design requirements of this product, I don't want it to, I'm going to be using a piston to kind of move each of these linkages. So 120 degrees is as far as I want it to be able to move. You can see again, just with that small design change, we can see very quickly that this now gives me the motion that I'm looking for. But I want a little bit more. I want a little bit more detail here. I want to know, for example, are these components going to be running into each other through their degrees of motion? So what I can do is run a couple of studies here. Let me just stop that. I have a traced path, I have a swept volume and area, and then we have a clash alert. So with traced path, all you have to do is select on individual points that you want this tool to follow, and it shows through its degree of motion where is that specific point going to land as it's sort of rotating around. We can also do a swept volume area. And in this case, I'm only concerned about the volume of my barrel. Again, this is just an outline of it. But when I select on that entity, you can see again, this is the volume of air that that barrel is going to be moving through. So if I go ahead and play this again, oops, I gotta start it from the beginning. There we go. You can see how it follows a traced path, and the volume fills this yellow zone right there. So my design is complete. I guess I could also show you real quick. We can do a clash alert as well. I don't know if these components will really run into each other, but to use the tool, you just select on the areas that you want to verify, are they going to run into each other, and you'll have to calculate it one more time. For the sake of time, I won't run that, but if these two components did run into each other, it would show on this timeline that there is a clash alert from that zone. So again, that would just be information I could use to make some necessary design changes. But at this point, I am satisfied with my design. I would like to inform some of my colleagues that my design has been complete. So I'd like to get a little bit of user feedback. So let me turn on a few components. So I'm going to be taking a couple of snapshots here. Don't need that one. And I'm looking for the barrel or container, excuse me. There we go. All right. So over on the right-hand side, we have some blog posts. As Jesse Ortman mentioned earlier, you don't have to jump back and forth between the web page. You can access all the same information directly inside of Mechanical Conceptual. So I'm going to create a new blog post, and we'll just call this initial, if I can spell it correctly, initial design. And we'll just put in a little bit of detail. All right, and we can take some really quick snapshots. Obviously, we don't want somebody to have to open this file up by themselves, so what we can do is add a screen clipping. Go ahead and box select the item that we're trying to grab here. There it is. But then I also want to show the motion study that I've done. So we'll say this is the traced path. I'm going to go ahead and turn that on. Again, I'm going to take another snapshot, add it in, put that on a separate line, and then we'll do the swept path. Don't need to see that anymore. There we go. And for anybody who might be concerned about any clearance, especially in this area, what I can do is just do a second snapshot, a little bit further zoomed in. And there we go. So I'm going to go ahead and publish this to the community. So as that's uploading, I'm just going to show you back on the community webpage. Again, I can't access it, but from Mechanical Conceptual, but we'll just go back a page here. These are examples of the blog posts like I am creating right now. So the concept design requirement, for example, they might have added in some details, took a couple snapshots, and then posted it. Anybody can see it. Anybody can comment on it. But to kind of fast forward through the process here, the design that I created wasn't perfect. Okay, there would be too much stress going on in these beams going across, and there are some other possible good designs that we could go with. So again, just kind of fast forwarding a bit, here are some of the different concepts that we have put together. So here's my initial concept that I already uploaded. These were pre-captured, by the way. We have a second concept. We can actually also play some videos here for anybody who doesn't quite understand what is that image showing. So we have concept number 2. We have concept number 3. Just let it do its thing here. So you can just see the level of detail that you can take this to. And again, all of it is in the conceptual phase. And then we have one more concept to show you. So some of these obviously are fairly complex, and they might be a little bit more intense than what we want. So this is where the collaboration comes into play. Down at the bottom, we've again, we fast forward in time here. So everybody has collaborated. They've decided that we all like the concept number 2. So that's the one that we're going to be moving forward with and taking it into the 3-dimensional realm, because this is currently just a layout sketch. And there is my blog post, by the way, which Jesse Ortman should be able to pull up now. And down at the bottom, we can comment, we can like. And let's just catch up there for a second. So like I said, we like concept number 2. I'm going to go ahead and edit that sketch. Here's the overall layout. And I can again move the components freely. I can drag them, or I can do a motion study just to kind of prove out the concept, but we've already done that in this case. So what I want to do at this point is, like I said, take this into the 3-dimensional realm. Everything is just sketch layouts. So what I'm going to do is tell Mechanical Conceptual to recognize each of these enclosed bodies as new components. So over on my Assembly tab, we have a Sketch to Component option, and all I have to do is deselect the items that I do not want to turn into individual components. Obviously, this item here was a representation of my my container. This was a representation of my barrel, and then this was a representation of my beginning frame. So I don't need new parts for that. Let me get this community out of the way. So I'm going to click OK, and keep an eye on the left-hand side of my screen here. You're going to see, once it completes, that every single one of these items is now going to have its own individual object. Making it very easy for me to manage them individually. There we go. And I can manually name them. That's those boxes that came up. I could have manually named each one of them, but we just stuck with the default names. So we're going to take this into 3-dimensional realm. So similar to a instant 3D inside of SOLIDWORKS, we can select on the enclosed geometry. We have an arrow which we can grab, pull out, and define that. And now we have our beginning component. So I'm just going to walk through this step by step with each of the different pieces. Define this using various dimensions. Set that to 20. Set this one to 20. There we go. Make sure I'm grabbing the right component here. Pull that forward 20. And I'm going to pull this one back a little ways. And I don't want these components to overlap one another, so we're going to be using an offset. So we have a couple of additional commands here. I want to offset that sketch plane. Actually, yeah. I'm going to offset it at a distance of 20. And then we will specify that linkage to be 20 millimeters wide. All right. So let's go ahead and activate our root. There you can see all of the components have now been created. The nice thing about this is you don't have to worry about doing any mates for these individual linkages, because I've already defined them in the sketches, in that layout sketch, to be interacting with one another. So you'll see a little bit later, once I complete my design, sorry about that, that all these pieces will interact with one another. But at this point, I'm noticing something. I'm missing a couple of beams here. Okay. I need this linkage to be able to connect to something. So I'm going to do a little bit of collaboration with Jesse Ortman here. I am going to send him a message through the internal communication system. So we'll just do a quick search for his name here. There he is. Let's go ahead and start up a chat. And let's send him a message, see what he has to say.
And I just got it up on my screen. Hello.
So I'm just going to ask Jesse, he could, Jesse was mentioning earlier, I'm over in Denver right now. He is back in Minnesota, so we're doing some communication long distance. So I'm just going to ask him, can you make that quick change to the barrel lifting frame? It's this component right here. And I'll just ask him to add in the extra beam here.
And just so you guys know, I've got the barrel lifting frame open on my screen in Mechanical Conceptual as well. So I'm going to go ahead and make the change here. Okay, so
let me know whenever you get that saved.
Yep, so I'm making the changes on my screen. I'm just adding some more stuff to the barrel frame, and then
One thing to note too, as Jesse's taking care of this, we are working on the exact same file at the exact same time. Okay, so if you try to do that inside of SolidWorks, you're going to get a message saying, "Hey, this has already been opened by so-and-so. You can only open it in a read-only state." Inside of Mechanical Conceptual, everybody can work on the similar projects at the same time, and as soon as somebody saves it, you'll see here in a second, I'll update my assembly and it'll tell me which components have been updated. So let me know whenever you get that completed, Jesse.
there you go. I sent you a little message there.
All right, and I'm just going to hit F5 to refresh my my layout here. There you go. It's telling me, hey, there was a change that was made to this individual component. Do I want to continue? Yes, I do. And there's just some changes that were made by a user. And we don't need that message, so there we go. We now have our extra beams put into place on both sides. So let's continue our design. Having a hard time typing here, sorry about that. All right, so we need to connect these linkages to the extra beams that Jesse Ortman has connected or created for me. So just so I have a direct line of sight, I'm going to hide a couple of components here. We don't need to see those right at this moment. And I am going to be editing this component right there. Oops. All right.
Some of the things you guys will see if you're experienced SolidWorks users is, Jesse is not really having to worry about structuring assemblies and sub-assemblies, sketches versus 3D objects. He's just doing everything kind of as he needs it. So we term that a single modeling environment. So it takes away a lot of the constraints you typically would see in a classical 3D CAD system, and allow him to design product structure, sketches, blocks, motion, parts, assemblies, and features all in kind of a single window here. And when he did the sketch to components, he can just choose at what point in time he wants to turn those into 3D objects or restructure his tree as he sees fit. So just a little advantage there for some of you old school SolidWorks users that are paying attention to that kind of stuff.
So another item I wanted to mention here, if anybody is using SOLIDWORks 2014, you might already be familiar with this, but you can very quickly mate these components together just by holding down the control key. And the nice thing about this is you can see what the result is going to be even before you click on it. So as I hover my mouse over this, you can see if I click down, that barrel is actually going to flip around on me. So I want this coincident right there. That sort of takes care of accidentally orienting something in the wrong position. Go ahead and apply a distance mate between these two. Again, looks like it is oriented properly. Let me get this chat thing out of the way. We don't need that anymore. All right, so I now have all of my components mated together. So let's bring back the items that I hid a little bit earlier. Show you. All right. And I have intentionally applied a mate that will prevent this barrel from moving, so I'm just going to have to suppress out that mate. There we go. And again, we'll go ahead and drag this in. As you can see, even in the three-dimensional realm, we can see the full degree of motion. On top of this, just like I did in the two-dimensional side, I can do a motion study of this three-dimensional form. So go over to our motion study. I'm going to go ahead and delete out these previous ones. We'll add in some rotary motion here. Oops, not around that. Accidentally picked the wrong item there. All right, and I want to rotate that at a specific angle, reverse the direction, and I'm not exactly sure what the number is. Let's just say 120 again, and we'll do that over a period of 2 seconds. And click OK. It's going to automatically calculate it out for us. Looks like I might have done it a little bit too much. Jesse, do you happen to remember how many degrees I need to do here?
I don't.
Let's just try 60. I can't remember the exact number, but you can just kind of see, again, the degree of motion. Just like in the sketch mode, we can do the trace path. So if there's a specific sort of detail that you're curious about, you can see it in the three-dimensional space. Where is that going to lay as it's going through its degrees of motion? And then we can, of course, do a swept volume area. And we'll do this component right here. It's a little bit harder to see what's going on in a 3D realm, but again, we're mainly concerned here about any interferences that are going to be occurring. So if there were any interferences, we could do, again, a simple clash alert. A couple other items I want to add in here. Let's get rid of that motion study. I want to, as you can see, this beam is sort of floating out in space, so I need to expand this out. Rather than me having to adjust the feature, what I can do is convert this part into what's called a direct edit. So I'm going to do, just so I can get a better line of sight to that component, I'm going to hide these extra wheels, and we will do convert to direct edit. Select the items that we want to be able to directly make adjustments to. We'll go ahead and click OK. And now when I select on those two faces, I get this tri that comes out, and I can now left click on the arrow and drag it straight out, and that change occurs immediately. So I don't have, again, I don't have to know what feature is controlling that geometry. All I have to do is pick the face that I want to be able to adjust and pull it in the direction I want it to go in. And the nice thing about this too is those, if I can find them in here, I think they're down at the bottom if I'm not mistaken. Just going to make sure I can find the, there we go. Oops. Looks like it might have lost it. Oh, there it goes. All right, and as you can see, the mates will automatically adjust as that geometry moves on us. Okay. So to add in a little bit more structure to this, I'm just going to copy all this geometry to the other side. Again, very easy. Oops, I want to do a mirror component option. I just want to make sure I get the right orientation here. So I want to get 1, 2, 3, 4, 5, 6, 7, and 8 components all copied over to the other side. I also want to put in a symmetric constraint. What this means is any change, any movement that I make to the original components is going to reflect on the other components over here. So because they are going to be moving at the same rate, I want them to follow one another precisely. So we'll go ahead and confirm that. Again, in our tree, we'll see that our list now updates to give us more mirrored components. And as I move this through its degree of motion, you'll see that both sides are going to be moving on us.
Looks pretty good.
Mm-hmm. So I think that might about do it for me. Again, at this point, I could save this out, add an additional message to my blog post. I could message Jesse here asking, hey, what do you think of the design? Should I make any changes? So everything is sort of tied to one another to really improve the communication between everybody. And so here is, I guess my credentials expired here. Go back over to Final Concept Design. Just got a few renderings, a few image captures. Again, we can play a video just to show what is the final result here. To demonstrate any concepts. And this photo view is rendered inside of SOLIDWORKS, so we can import in images even if they aren't created directly in Mechanical Conceptual. All right. Jesse, did you have anything else you wanted to discuss?
I did a couple things here. Do you want to just pop the screen over to me for a second?
Sure.
I'll just show a couple things here real quick.
There you go.
Just to show you guys, this is the barrel frame that I had opened that I had modified, and all I did was actually hit the save command up here, and that immediately pushed the changes up so he had access to them. A couple of the things, during the chat sessions we've been having, you can take screenshots live here and send those across through the chat window. So if I click on that, it'll snapshot my screen and send that over to Jesse. And then when he clicks on the snapshot on his screen, it'll orient the model right back into the same position that I have on my screen at the same time. So we can just, and you can do some highlighting and, maybe you want to circle a region and say, take a look, where is it here? What am I missing here? Take a look, some redlining tools. And then he'll see that on his screen too. I've got to close out of the snapshot. So I could do that, point arrows at things and say, hey, check out this area, and just continually send snapshots over to him. So he'll get the annotation and the positioning real time up on his screen as we're working and collaborating. The other thing we can do is we can start in the chat window what's called a co-review, where this allows us to share mouse and keyboard control across the session real time too, so we can each rotate and annotate sort of real time on the products. So for anybody running multiple sessions on the same data, that kind of stuff is really nice. One of the questions that came up through the session was, how can I communicate with my SolidWorks software? I think Todd answered in the chat window, but just to show you guys, we can import data here. So I can bring in, directly from SolidWorks. So it's basically like a file open. You can convert SolidWorks 3D CAD models into mechanical conceptual. And we can also go the other way and do an export and send the files back to a SolidWorks format so that you don't have to recreate any 3D geometry at any point in the process. So those are a couple of things I wanted to add there.
When you have a moment, Jesse, I'd like to show that 3D snapshot.
Okay, go ahead and take control back.
Oh, sure. All right, you guys can see me, right?
Yep.
Okay. So yeah, the snapshot that he sent over, it's not just a two-dimensional image. When I left-click on this, you'll see that my model is going to there we go. It'll automatically orient itself to the same position as what Jesse Ortman had taken a snapshot of. So even though we're working in separate documents, the tool recognizes that this component is of that snapshot I took, Jesse Ortman took before. And so this really gives me a better idea of what is the area that he is concerned about. So you can circle geometry, you can point out certain information, and it will orient it exactly to the direction that I should be looking at it from, so I understand what he's trying to tell me.
There you go. Let's see, any last, I see no other questions in the chat box. If anybody has any additional questions, you can type them in now. We've got just a few seconds left here, a few minutes. Todd and Elton are also available on their end of the meeting to answer questions as well. So we'll just let you guys, if anybody wants to ask in the webinar chat box there or the question box anything additional, feel free to do that now. We'll wait a second or two here for questions to come in. And if you guys are looking at next steps here, your main point of contact here at Alinex to initiate the next step would be Mike Lamora. So if you want to get a hold of us or him specifically for next steps on mechanical conceptual software, that's your main contact, Mike Lamora. Let's see, anything additional here coming in on questions?
I'm not seeing anything.
Yeah. Hey, Jesse, real quick while we're waiting, you want to hit your little compass in the upper left-hand corner and just show, you know, kind of to the left is the 3D apps. So this is where we picked our mechanical conceptual tools. If you hit the down quadrant, this is where you guys can also get in and do some structural validation on your model. So we do a couple of FEA type studies here. You guys can do way early on some of these 3D objects you're creating to validate stresses, you know, thermal and vibration type things, frequency. So that is another product design simulation app. So we have the mechanical conceptual app and we have the structural validation app. And keep an eye in the future. We're just going to continually develop more apps here for you guys, handling different you know, different requirements in your early design process. Mike Lamore's email in the box there. Well, good. I think if you gentlemen don't have any other last statements here, we can go ahead and wrap it up. Todd, Elton, Jesse, you guys got anything else to add?
Nope. Good.
Okay.
Nope. Thanks, everyone. Appreciate the time today.
Yeah. Thank you very much.
Yep. Thanks, everyone. We'll go ahead and close the meeting now.